Ladies and gents, my name is Brandon Stover. Welcome to the How to Solve Climate Change course from Plato University. Causes, systems, obstacles, solutions to this global challenge is what you're going to learn here today. When you're ready to learn more skills, join us for free at plato.university. Let's get started with today's lesson. Explain succinctly what carbon mineralization is from first principles.
Carbon mineralization, also known as mineral carbonation or carbon capture and storage, is a process that involves capturing carbon dioxide emissions from industrial sources or directly from the atmosphere and converting it into stable carbonate minerals. This process mimics the natural geological process of weathering, where CO2 reacts with certain types of rocks, such as basalt, to form solid carbonates over extended periods. The goal of carbon mineralization is to lock away CO2 permanently in a solid form, reducing its presence in the atmosphere and mitigating the effects of climate change.
Why does carbon mineralization help to solve climate change?
Carbon mineralization is a promising approach to combat climate change for several reasons. First, it offers a permanent and safe storage solution for CO2, effectively removing it from the atmosphere and preventing its release back into the air. Unlike some other carbon capture methods that store CO2 in liquid or gaseous form, mineralized carbon is chemically stable and will not contribute to future greenhouse gas emissions. Second, the process utilizes natural geological reactions, making it a low-energy and environmentally friendly option. Lastly, carbon mineralization has the potential to scale up significantly, given the abundance of suitable rock formations globally.
Steel man the other side. Why would carbon mineralization not work to solve climate change?
While carbon mineralization shows promise, it is not without challenges. One major concern is the limited availability of suitable rock formations for large-scale implementation. For carbon mineralization to make a substantial impact on climate change, vast amounts of CO2 need to be stored, and identifying and accessing adequate geological sites may prove challenging. Additionally, the process itself requires energy for CO2 capture and mineral conversion, which could potentially offset some of the environmental benefits.
Who benefits most by implementing this as a solution?
The main beneficiaries of implementing carbon mineralization are society as a whole and future generations. By effectively sequestering CO2 from the atmosphere, carbon mineralization helps mitigate climate change impacts, such as extreme weather events, sea level rise, and disruptions to ecosystems. Industries that adopt carbon mineralization technologies can also benefit from meeting emissions reduction targets and potentially gaining carbon credits or incentives for sustainable practices.
Who is harmed most by implementing this as a solution?
The direct harm caused by implementing carbon mineralization as a solution is relatively limited. However, there could be potential challenges for communities living near the sites where CO2 is captured and stored, especially if there are concerns about safety, land use, or environmental impacts. Careful planning and stakeholder engagement are essential to address and mitigate any adverse effects.
How feasible is carbon mineralization to implement as a solution?
Carbon mineralization is technically feasible and has been demonstrated in pilot projects and laboratory settings. However, scaling up the technology to achieve significant carbon sequestration and integration with existing industrial processes poses challenges. The feasibility also depends on the availability of suitable rock formations, the cost of the process, and the establishment of policies and incentives that support widespread adoption.
How does carbon mineralization work as a solution to climate change?
The process of carbon mineralization involves several steps. It starts with capturing CO2 emissions from industrial processes or directly from the atmosphere using various capture technologies, transporting the captured CO2 to suitable geological formations, typically underground, injecting the CO2 into these formations, and allowing the CO2 to react with certain rock minerals, such as basalt or peridotite, to form stable carbonate minerals over time. This transformation effectively locks away the CO2 in solid form, preventing its release into the atmosphere.
What is a real-life example of this solution being implemented?
The Carbfix project in Iceland is a real-life example of carbon mineralization being implemented. In this project, CO2 emissions from a nearby geothermal power plant are captured and injected into basalt formations deep underground. The injected CO2 reacts with the basaltic rocks, forming carbonate minerals within 2 years. Monitoring at the site has shown that over 95% of the injected CO2 has been mineralized, indicating the effectiveness of this approach.
For carbon mineralization as a solution to work, what innovation or policy needs to be created?
To make carbon mineralization a viable solution on a global scale, several innovations and policies are necessary. Technological advancements are needed to improve the efficiency and cost-effectiveness of CO2 capture and mineralization processes. Research and development should focus on optimizing the choice of rock formations and enhancing the rate of mineralization. Additionally, supportive policies, such as carbon pricing and incentives for carbon removal projects, can encourage industries to adopt and invest in carbon mineralization technologies.
Right now, you're speaking to passionate students who want to actually solve problems like these. What top 3 skills should they study so that they actually have the ability to do so?
A strong understanding of geological formations, mineralogy, and rock chemistry is crucial for identifying suitable sites for carbon mineralization and predicting the long-term stability of stored carbonate. Students should study the various methods and technologies for capturing CO2 emissions from industrial processes and learn about transportation and injection techniques for safe and effective CO2 storage. An understanding of climate change policies, carbon markets, and economic incentives is essential for advocating for the integration of carbon mineralization into climate mitigation strategies and developing viable business models for its implementation.
To further understand carbon mineralization, brainstorm and propose innovative ways to integrate carbon mineralization technologies into specific industries like cement, steel, or waste management.
Thank you for taking the How to Solve Climate Change course. If you want to learn the skills to solve this global challenge, join us for free at plato.university for exclusive content, extra resources, and actionable exercises with every lesson. This course was produced by Plato University, where students turn passions into purpose and learn skills to change the world. Learn more at plato.university.